What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the Tutor, and today we're going to be talking about finding the range of a function, both using the graph and algebraically. There are a few methods of finding the range of a function. Remember that the range of the function refers to all the values that we can get out of our function with all the inputs that are allowed into our function. For this reason, it is a lot easier to find a domain than the range, because it is a lot easier to tell which values I can exclude from my domain rather than to try to figure out which values I'm going to exclude from my range because I just can't get them. Remember that some functions, like the x squared function, we can clearly see that no matter what we put into the function, we're only going to get positive numbers out or zero. So it's very easy to see what happens to a function like that. But other functions might not be as easy. Now, as always, the easiest way to find it is going to be to look at the graph. If you have the graph available, you can see exactly how low or how high the function goes and which values we can exclude. Another method that a lot of people use is they try to switch the x and the y and solve for what they call the inverse of the function, but sometimes that method gives us a little bit of trouble. What I'd rather do is try to see the characteristics of each function, because most of the functions are going to be just composed of these basic ones. And if we know the basic moving parts of these functions, we can tell where they go. So we will be going over certain particulars about functions and which ones have freebies, because there's also some functions that we can just say, oh, the domain and the range are both all real numbers no matter what the function looks like. So let's take a look. Let's start with the easiest case, which are the lines. The range of a line with a slope of m is going to be from negative infinity to positive infinity. As long as this line has some kind of slope, you can be sure that your range is going to go from negative infinity to positive infinity, and we can write this like this. Nope, not a brace, it's going to be a parentheses, negative infinity to positive infinity. For a horizontal line has a slope of 0, and when the slope becomes 0, all we have is a y-intercept. In this case, the range is only going to be that value. That's it. So my range is only going to be whatever b is. In the case of a vertical line, we know that's not a function. Therefore, we're not going to discuss it. However, I like to point out just how to write the equation of the line, because a lot of people forget how to write the equation of a... Of course. Some students forget how to write the equations of these lines. So let's go ahead and remind ourselves how to write it. It's simply x equals whatever the value of x is at the vertical line. And that's going to be the equation of a line. But like I said, we all know that vertical lines are not functions. Horizontal lines are functions, but vertical lines are not. Now let's go on to quadratics. Quadratics are going to be of the form f of x equals ax squared plus bx plus c. Now sometimes b might be 0 or c might be 0, but in either case, a cannot be 0, because if a is 0, then we have the case where this is just a line. So in the case of quadratics, we have to look for the vertex. Remember that parabolas come in two flavors. In general, it's either going to face up or it's going to face down. And the range begins at the vertex. So if that is the case, we're going to have a range that starts here and goes all the way up, the y value of the vertex. And if we go here, we're going to have the case of a range that starts at negative infinity and stops at the vertex. So let's see how we find the vertex here. To find the vertex, we're simply going to take our quadratic and identify the coefficients of our terms. This will be a, b, and c, and so we're going to say a, b, and c. For this, we're not really going to need c, but we are going to need a and b, and we're going to say x equals negative b over 2a. This right here is going to be the x value of our vertex. So if we want to say vertex, negative b over 2a. Now to find the y value, which is what we're really interested in, we are going to take whatever we get out from this little expression, from x, we're going to plug it back into our function, And whatever we get, that's going to be the y value. So I'm going to write that notation as f of negative b over 2a. Now let's take a look at this example to see how to apply x equals negative b over 2a and then that to find the vertex. First, note that the coefficient of x squared is negative. Therefore, this parabola is going to open upside down in some way, somewhere on the plane. A is negative 1. B is 6. And we only need those two. So now we're going to go over here. We're going to say x equals negative b, and b is 6, over 2 times a. And a is negative 1. And we get negative 6 over negative 2, which gives us a positive 3. So that right there tells us that 3 is the x value of our vertex. Wherever our parabola ends up, it's going to end up with an x value of 3. Now let's find the y value. And for the y value, all I have to do is take whatever I got for x and plug it into g of x. So I'm going to say g of 3 equals negative 3 squared plus 6 times 3 plus 1. And now we have here negative 3 squared is 9, so this is going to be negative 9. 6 times 3 is 18 plus 18 plus 1. And finally, negative 9 plus 18 is 9 plus 1 is 10. That means that our y value that corresponds with this x value of 3 is 10. Our vertex is going to be 3, 10. And now that we have our vertex, we can make the following conclusion. Since our parabola opens up like this, that means the highest value is going to be a 10. So the range is going to be from negative infinity all the way to 10, including 10. Now, if you're curious about the domain, which you shouldn't be, this is a polynomial. So just for completeness, I'm going to say the domain is going to be negative infinity to infinity, because since it's a polynomial, we know the domain is going to be negative infinity to positive infinity. Now, for the cubic functions and other odd degree polynomials, it's going to be very simple. The range is simply all real numbers. The reason for this is that when you graph a cubic, you're going to end up with this situation or some situation where it starts up here, comes down, and goes all the way down again. Anytime it's an odd degree, you're going to have a situation where it starts at the top, ends at the bottom, or it starts at the bottom, ends at the top. So your range is always going to be all real numbers. Taking a look at it in the expression-wise, either f of x is going to be ax cubed plus blah, 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 or you can have a situation where g of x is x to the some odd power. The leading coefficient doesn't matter, because even if this gets flipped, you're still going to end up in a situation where one of this is going to go to the top and the other one is going to go to the bottom. So the range is simply going to be all real numbers. Now for the square root function, first let's take a look at the characteristics of the graph. Notice that the parent function starts at 0 and continues all the way to the right forever. Also, it grows forever in the y direction. This one over here says negative square root of x minus 1, and whatever happened here ended up flipping this function and doing this over here. But the most important point is this one, the beginning point, because that's going to tell us where the range starts. And we already know how to find that point, because we already know how to find the x value of that point. The x value of that point is simply going to be the smallest x that I can have. Now, by looking at the domain of this one, we know that the domain goes from 0 to infinity. So here I'm going to say domain is going to go from 0, including 0, all the way to infinity. Now, since the lowest value we can plug in for x is 0, it stands to reason that we're going to plug it in and we're going to get square root of 0, and that's going to give us f of 0 equals 0. So that point right there is 0, 0. So that's where the range begins. And since I know that this function opens upward, I know my range is going to go from 0 all the way to infinity. So I'm going to say range It's going to start at 0 and it's going to go to infinity. In this case over here, we can do the same thing. First, we're going to find the domain. The domain, we're going to plug in whatever's in here. We're going to set it greater than or equal to 0. So we're going to say x minus 1 is greater than or equal to 0. Isolate x at 1 at 1. We know that x has to be greater than or equal to 1, which means that the smallest value we can plug in for x is 1. So let's go ahead and plug that 1 and see what it gives us. 1 minus 1 equals 0, and we end up with g of 0 equals 0, which also makes sense. It's letting us know that it starts at 0. But since there's a negative in front of our function, we know it's going to flip. So therefore, that gives an indication that this 0 is actually the topmost point. So range, it's going to go from negative infinity, and it's going to stop at 0, including 0. Let's look at another quick example that might be a little different so that you don't get the impression that all these functions start at 0. First, we're going to find our domain. And the domain is going to be, we're going to take whatever's inside, and we're going to set it equal, greater than or equal to 0. From here, we're going to isolate x. So we're going to say subtract 2, and we get that negative x is greater than or equal to negative 2. But of course, we're not looking for negative x, we're looking for x. So we're going to divide everything by negative 1. Here on this side, we get x. Since we divided by a negative, we're going to flip this sign. So we're going to say is less than or equal to, and we have a 2. So our domain tells us that x can be less than or equal to 2. So we're going to write it as negative infinity, and it stops at 2. Now, in this case, the largest value we can use is 2. We're not going to evaluate for infinity, but we're going to find that vertex. And that vertex is going to be, or that starting point is going to be whenever x is 2. So let's go ahead and plug into here to see where the y value of that point is. So I'm just going to put it right here. And I'm going to call it v for vertex for now. And I'm going to say this one is at 2. And I'm going to find that other value. So now, when I plug in h of 2, I get negative root 2 minus 2 plus 3. This gives us 0. And all I get is that h of 2 equals 3. And that gives us the y value of that. So now we know that our vertex, or that starting point, that weird starting point for the square root function, is going to be at 3 on the y value. And since it's a negative, we know it starts at the bottom and it stops at 3. So we're going to say that our range is negative infinity and stops at 3. Now, out of all the functions that students have the pleasure of working with while in high school algebra, the one that receives the most hate is going to be the rational function, and for good reason. They have these weird things called asymptotes that nobody knows how to spell because they have a silent P, and they go in all sorts of weird shapes. In this case, we have two asymptotes. We have a vertical asymptote and a horizontal asymptote. In this case, we also have two, but now in this case, we have three. And up to this point, you've heard that we cannot cross asymptotes. And in the case of vertical asymptotes, that is always the case. We do not cross vertical asymptotes because we never divide by 0. It is not allowed. Horizontal asymptotes, however, are a little different. Notice that in this case, we can cross the horizontal. In this video, we're mostly going to be dealing with the simpler case of the rational function. This will come much later. First, let's look at the simple case of the rational function f of x equals 1 over x minus h plus k. In this case, the denominator has a variable, but the variable is in the first degree. We're adding or subtracting some number, and then after we're done with this function, this part, we're adding a number outside. So let's take a look at an example. In the case where k is 0, there is no k. In here, I could have written this as plus 0, but we usually see them like that. So let's take a look at that. First, let's find our domain, because that's going to be important. The domain is going to be anything that does not make the denominator 0. So in this case, my domain is going to be everything except negative 2. And so for now, I'm just going to write it as x cannot be negative 2. We're going to write it in interval notation a bit, but for now, that's just for my notes. Now, let's think about the range now. What does the range mean? Well, in the context of this, it means if we cannot use negative 2, but we can use every other value of x, which values of g of x can I get from that? And it's important to note one thing. This is a fraction. And the denominator can never be 0 because we cannot divide by 0. But also, because the numerator is a number, this fraction can never be 0. There is no single value of x that would ever make this function 0. And for now, that's our range. So we're going to say domain. We're going to start at negative infinity for our domain, and we're going to stop at 2, at negative 2, not including negative 2, union, negative 2, and then we can go all the way to infinity. Based on that, we know that this fraction can never be 0, and that's the only value that this is not going to be. So we're going to say the range is going to start at negative infinity, it's going to stop at 0, it's going to skip 0 and go from 0 to infinity. Now let's take a look at a case in which k is not 0. Here, we are applying the variable in the first degree as a denominator, but then after we apply this function, we have to add a 2. Now, the domain, I'm going to write it up here. I'm just going to say for now, x cannot be 4. We know that x cannot be 4 because if we plug in 4, we get 0, and 1 over 0 is nonsense. Now, are there any values that this function cannot return? Well, similarly to this one, the fraction part could never be 0. This could never be 0. And because this could never be 0, this could never be 0. But let's pretend it was 0. If it was 0, then the function will return 2. But since it could never be 0, it's always going to be either a little more than 0 or a little less than 0, this function will never return a value of 2. We will never get 2 out of this function. And so we would say that the range, and we're now going to write it in interval notation, we're going to start at negative infinity all the way to 2. We're going to skip 2, and we're going to go all the way to positive infinity after that. And let's fix the domain. Starts at negative infinity, stops at 4 without including 4, jumps, and then starts at negative 4 again, and goes all the way to infinity. And if we look at the graphs of these two functions, we could see that the breaks happen exactly where the horizontal and the vertical asymptotes happen. There will be other cases where we need to analyze the function more if you end up having a square in the denominator or some square root in the denominator. There will be further analysis. But this is just a basic way of finding the range and knowing what the range is for a function like this. And finally, we get to the absolute value function. Now, the absolute value function is simply two lines stuck together at some point, and we restrict the domain on either side. So, because of that, we end up getting a vertex. Now, that vertex is very useful because much like the parabola, if we can find the location of the vertex, if we can find the y value of the vertex, we know where the range begins or where it ends. So, it's going to be important to find that point, the vertex. And how do we find that vertex? The vast majority of your absolute value functions are going to look like this. The only difference they might have is they might have some multiple in the front, some number here like a 2, but they're mostly going to look like this. And the ones that do not look like this could be reduced to something like this. So the most important point here is either the maximum or the minimum of this function. So let me go ahead and get rid of this because we want to know where the vertex is. If we can figure out if this function does this or that, all we need to find is that point to tell us where the range begins. But in this case, the trick is to simply ignore anything that's attached to the absolute value part of the function. So if there's a multiple here, there's a negative, for now you're going to ignore it. And whatever's left over, that's going to be the y value of that point. And that's all we care for now. We care about the y value. So we know that the y value is going to be -4. So we know that the range is going to either start at -4 and go to infinity, or start at -4 and go down to infinity, to negative infinity. And in this case, then we look at this. Does this function open up or down? And in this case, it opens up. So we know that -4 is the lowest point that this is going to get to. So this is going to be the lowest point. So then my range is going to be -4 all the way to infinity. I do not need to graph it to know that that's going to be the lowest point and that it's going to open up. And just to really drive the point home, let's take a look at this one. As we know, the domain is all real numbers. This function can take any real number and return a value. So we're going to say domain -infinity to +infinity without including either. And the range, well, let's ignore everything that's attached to the absolute value, like that. We're going to ignore it, and we're going to see that there's a +7. So the y value is going to be a 7. So something's going to happen at 7. And this multiple right here, this constant, is a negative. So we know that this function is going to open upside down. And this y value is going to be the highest y value here. So we're just going to say that the range is going to start at -infinity and it's going to stop at 7, including 7. That is all for today. Thank you for stopping by. If you like the video, make sure you hit like. If you want to see more content like this, make sure to hit the subscribe button. If you have any questions, comments, concerns, or emotional outbursts, make sure to drop them in the comments below. Thank you.